So we'll just take a quick look at the difference in properties between our kinesiology type tapes and our dynamic tape, which we use far more biomechanically. So our kinesiology tapes stretch longitudinally. They don't stretch sideways, which can be important from a kinesiology taping point of view, but in terms of taping biomechanically, that can provide a restriction to range of motion in certain directions and limits us crossing the midline and spiralling and so on. They have a little bit of recoil, but it's not overly strong. And if we have a quick look, in order to get this mechanical effect, we need to cross the joint and go on in a short position so it acts like a bungee to be able to create some resistance to motion and then spring back in the opposite direction. So if we actually shorten up here and put a little bit of tension on, not stretch fully, but just a small amount of tension so we're going to create resistance immediately, what we tend to find with this is that we're going to run out of room pretty quickly. We can use this mechanically to provide a bit of a restriction of motion using that rigid endpoint. If we want to allow full range, we can allow full range by putting it on in that extended position, but then we don't have much of a mechanical effect in terms of decelerating motion and assisting motion. The dynamic tape stretches much further. It doesn't have the same rigidity to that endpoint, and that allows us to get on in a short position and still get through full range. And it stretches also in all directions so that we can cross the midline. Our muscles aren't all just longitudinal, so it allows us to more closely mimic the action of muscle by having recoil in multiple directions and a number of other benefits. If we do the same thing and we shorten this up, and even if we exaggerate and bend Nick's wrist up as well, get our tension on, what we'll see is that we can still, if we're strong enough, get all the way through range of motion and have this much stronger resistance and recoil to motion. So much more effect on decelerating motion or assisting motion, as the case may be. So we're just looking at the forces in the tapes, and we're going to compare a kinesiology tape with our original dynamic tape, and then also with the dynamic tape Eco to show. This tape actually is one of the stronger ones, has a bit of force coming in towards the end of range. But what you'll notice with these kinesiology tapes, they all follow a pretty similar pattern, as well as a lot of the four-way stretching nylon tapes, is that when we stretch them through range, we don't get any significant resistance. So that's not registering on here, and this is set to kilograms. That's 0.1 or less than 0.1 or 100 grams. Okay, we only start to get force coming in as we get to the end of the tape, which is there, and now it can load up, but I actually can't stretch the tape any further. So I've reached that rigid endpoint of the tape. So in terms of resistance through range, we really don't get much in the way of deceleration, load absorption, or assistance back the other way. We just get a real block at the end of the tape predominantly. So here we have the dynamic tape, or the original dynamic tape, and we'll just again look at the measurements, and what we see is actually as soon as we start to move, there's nearly 2 kilograms of resistance straight away, nearly 3 kilograms of resistance straight away. So we don't have to go very far, and we start getting significant force into the system. The tape is also viscoelastic, so basically the stiffness is dependent on the rate of strain. In other words, the faster we stretch it, the stiffer or the more resistance we get. So if I go a little faster here, okay, now we're at 4 kilograms. If I go faster again, okay, now we're at 8 kilograms, and so it goes on. And so with double layers, we can quite easily be getting 15 kilograms or more of resistance through range without locking or limiting range of motion at all. So now we have the dynamic tape Eco, and this hits a higher resistance sooner in range, so it doesn't need as much stretch to hit the same force. And we use this where there's not a lot of motion occurring, so it might be joints and ligaments, something like our medial elbow, our ankle sprains, and we want high resistance to help decelerate and manage those forces, but we can't use the movement to create the tension in the tape because there isn't much movement. So what we'll see here is as soon as we start to go, we're getting very high forces with really minimal stretching at all. We're at 3.5 kilograms with perhaps a centimetre, probably well less than a centimetre of stretch. Again, if we go a little faster, a little further, now we're at 6 kilograms straight away. There's 6.5 kilograms. Again, if we go very fast or we double this up, we can be hitting very high forces immediately in range. So we can use that very nicely to help manage the loads through some of those other structures.